All right, let's take a look at one of the beautiful things about the incompressibility of a liquid. If we think about applying pressure to a cylinder that has a non-compressible, non-density changing liquid in it, and we apply a force to this cylinder, the pressure generated in the liquid is going to be equal to the force divided by the area. In this case, with the small cylinder, I have 100 Newton force divided by 0.01 meters squared. All right, this is going to lead to a 100 divided by 0.01, which is 10,000 newtons per meter squared. And a newton per meter squared is called a pascal. Pascal is the unit of pressure in the metric system. So when we see this 10,000 newton per meter squared, this pressure is exerted throughout the hydraulic system that is connected so that fluid can flow and pressure can equalize. Once we see this, we can go back and say, hey, what happens on this large cylinder where I have a large surface area and all of a sudden this pressure is exerted based upon the small one? Well, here we know that the force is going to be equal to, look, force divided by area equals pressure, but if I have area and pressure but not force, I can say multiply both sides by area. So now I have pressure times area, P times A, equals force. In this case, I have 10,000 newtons per meter squared times 1 meter squared leads to a force of 10,000 newtons. This is the power of hydraulic pressure and hydraulic mechanisms, is that we can get a force multiplier. Now, the flip side of this is that if I move this by, say, 1/10 of a meter, this is going to move by much less because the volume moving through this tube is lower. But this concept of using hydraulics as a force multiplier is what allows hydraulic machines to be so used in our society, because we can take a small cylinder, apply a relatively achievable amount of force, and get a huge amount of force on the other end, but with a much smaller movement.